Expansion. Expansion is the increase in the extent, volume, and length of an object due to heat or any pressure. Matter, as we know, is either solid, liquid, or gas. Today in this video, we're going to discuss and focus about the expansion of solids in general. Expansion of solids. The particles in solids are too compact, and the particles are too near each other. As for this reason, the expansion that happens occurs spherically in all directions, but it can be broken down into three categories. Linear expansion is the increase in length of a substance due to heating. Now, let's move into the numerical explanation. For this explanation, let's pick a rod and call it LO before heating. And after the process of heating, let's call this rod L. Now, the question becomes, what's the change in length? Change in length is equals to final length minus length original. Now, let's go into the advanced one. The change in length is directly proportional to the temperature, or the change in temperature, meaning if the temperature increases, then the change in length is going to be increased. The change in length is also directly proportional to the original length. Third, and most importantly, the change in length is directly proportional to the coefficient of linear expansion, or alpha. The coefficient of linear expansion is the increase in length of a 1 meter of a rod by a given substance when its temperature increases by. Change in length is equals to LO alpha change in temperature. Now, a person might want to calculate final length. So, let's help that person calculate it. Change in length is equals to L minus LO. L minus LO is equals to LO alpha change in temperature. Now, we want to find the final length. Final length is equals to LO plus LO alpha change in temperature. L is equals to LO 1 plus alpha change in temperature. This areal expansion it's the change in area of an object. Let's call AO the original length and A the final length. So the change in A is going to be A minus AO, just like we did in the linear expansion. The change in A is also directly proportional to the original length. The change in A is also directly proportional to the change in temperature. The change in A is also directly proportional to B, or what we call beta, is equals to AO, or area of original, beta, change in temperature. A person might ask now, what's the correlation between beta and alpha? So area is equals to length times L, length, or length square. So since area is length square, so the value is also going to be squared in area. Length square is equals to LO square, 1 plus alpha change in temperature square. 1 plus alpha change in temperature square. This becomes 1 plus 2 alpha change in temperature plus alpha square change in temperature square. Alpha square is going to be less than 0, and it becomes 1 plus 2 alpha change in temperature. The area, the change in area becomes AO 2 alpha change in temperature. Beta is 2 times alpha. Volume expansion is the change. Volume expansion is the change in length, the height, and the width of an object, or what we call 3D objects. As we did in the linear expansion and the areal expansion, let's call the original volume VO, and after heating, let's call it V. So the change in V becomes V minus VO. Now let's go to the advanced one as we did before. Change in V is directly proportional to change in T, which is change in temperature. As the temperature increases, the volume increment becomes increased. The change in V is also directly proportional to VO, or volume original. Change in V is directly proportional to gamma, or what we call cubic linear expansion. Alpha change in temperature. As I said before, alpha is less than 0, so we have to cancel it, which meaning it gives the result 1 plus 3 alpha change in temperature. After the whole process is done, cubing. Now the change in volume becomes VO, 3 alpha, change in temperature. Now we know the correlation. Gamma is 3 alpha. This was all about the expansion of solids in general. We have seen the linear expansion, aerial expansion, and volume expansion. Thank you guys for listening.